Hi, we are here with another episode of tutorial series of minor repair. The purpose of this video is to show the use of multifunctional test fixture in troubleshooting and repairing Antminer Hashboards, which is S9 here. In a multifunctional test fixture, we have to insert the specific memory card of each model that we are trying to troubleshoot, and I've prepared the S9 memory card earlier and put it on the tester. For applying this tutorial and troubleshoot the problem, we will need a test fixture, 12 volts power supply to turn on the hashboard, a multimeter which we have soldered two needles to the top of the probes and put on heat shrinks to avoid electric shortages. If you pay attention to this picture, the test points are between heat sinks, and we need those needles to go through these heat sinks and measure those test points without any electrical short circuit. These were for troubleshooting, and for repairing and replacing the faulty chip, we will need the soldering iron, heat gun, preheater, flux paste, stencil, solder paste, spare chip, tweezers, solvent, and brush for cleaning the mess. We start by turning on the test fixture. Needless to say that we have connected the test fixture to the computer using the USB serial converter, which the data transfer is shown in the lower video. We need to wait a bit and let the test fixture to get ready. Here you see that I've marked the heat sinks in the sequence of the signal flow to make it more comprehensible. In a S9 hashboard, the signals start from the chip here 0, 1, 2, 3, 4, 5, 6, 7, 8, and comes to this one, and then it goes to here, which is 30, 1, 2, 33, 4, 5, and the last one is chip number 62 in the corner. I'm waiting for the boot up process of the test fixture. Well, now we press the green button to start the hashboard test. Here I expect after pressing the start button, the reset signal starts to flow and show me the faulty chip. The testing process starts by pressing this button. Well, here you see that on my screen it shows that 24 ASICs has been detected. Here, chip number 23 and 22, I measured the reset test point of the chip number 22, and you see that I have 1.7 volts here, and I come to chip number 23 and you see that I have somehow no voltage on RST test point, and also all the chips after that doesn't receive the signal. Here's the point. The chip number 23 has the RST signal before and cuts off the signal after. And that's the reason which shows the chip number 23 is faulty. Actually, chip number 22 and the circuit between 22 and 23 may be faulty too, but we can check that by measuring the continuity between two chips. We saw that the chip number 23 is more likely to be faulty. This hashboard is been working inside mineral oil, and the lower heat sinks tend to fall easily, so we need a different approach to replace the chip. I'm saying it again, we do not replace the chip like this in normal situation, and this is because the board has been working in mineral oil. For this, I adjust the heat gun to the maximum heat and low, and I hold it on the heat sinks for 10 seconds to separate the lower heat sink. On the other side, for an easier process, I need to separate some of the upper heat sinks of the neighboring chips to in order to prevent unwanted touching of those heat sinks. The next step is to put the hashboard on the preheater. Well, here I'm trying to replace this chip number 23, and as I said earlier, this process is because the board is being used inside mineral oil. I've prepared some used chips previously, which I have picked them from another hashboard, and I'm gonna show the reballing process of these chips. You have to clean the two big negative and positive pads in the center and let go of the solder on the smaller pads. Then clean the stencil with a thinner end brush. As you see here, I put the hashboard on the preheater and I'm heating it up a bit to let the chips come off easier. The important thing here is that because the hashboard has been working inside a mineral oil, we are taking the advantage of the preheater to replace the faulty chip, and in other cases you hold the heat gun straightly beneath the lower heat sink of the chip, and that will be more helpful. Okay, after replacing the marked chip, we come to the troubleshooting again. We start the power and press the test button to see the results. Here you see that the hashboard is working fine and all the signals are flowing through, and it's calculating the nonce packets and its temperature is increasing. So I know that the temperature will not go further than 75 degrees, so I didn't put a fan on the hashboard, but you have to have a fan beside you to cool the hashboard down when needed. Mostly when it takes time to troubleshoot the hashboard, it will heat up, and in case it starts to work, the temperature will go higher and the test fixture will turn the hashboard off when it goes further than 85 degrees Celsius. You see that the sensor pattern and temperature values are okay, which shows that the hashboard is working fine. Thank you for your precious time, and I hope this video was helpful. If you have any problems or questions about this tutorial, don't hesitate to message us and let us know. Thank you.